Hello, my name is Benjamin and next to me is sitting Sheng Mei, and we want to talk about mobile internet and want to give you a little overview. At first we want to give you our classification. We divided our topic mobile internet into 6 or better 5 little topics. At first Sheng give you our preposition. Then I want to talk about 2G, which contains GSM, GPRS, and Edge. And after that, Sheng Mei would tell you about 3G, which contains UMTS, HSPA, HSPA+. After that, I want to talk about 4G, LTE, and LTE-Advanced. And last but not least, next generation mobile network. And in the end, our list of references.
No problem. Hello, my name is Mei. Now I tell you something about our preposition. And before the digital generation, we had analog communication. The ANET was the first mobile radio system for the telephony in the BLD. It was an analog net with manual mediation. By leaving the land sites, the connection got terminated. The B-net was also an analog mobile radio system from 1972 to 1985. New was connection by yourself to both sides, phone net to radio net. A big problem was the fact that you have to know where your receiver is. Supported limited use of ramming. The transmission was encrypted. Everybody with radio sets could listen to your call. For encryption, both participants had to use special tools. The C-net was an analog and cellular mobile radio net for data mobile from 1985 to 2000. It's only in Germany, Portugal, and South Africa that provided roaming and was the motivation for the development of GSM.
The second generation of mobile internet started in 1992. It was GSM, Global System for Mobile Communications. It's a standard for full digital mobile networks. It was used for telephony and also for circuit switched and packet switched data, transmission and short messages. Different between landline are more requirements, like user authentication, channel access methods, mobility management like location update and handover when you come from one base station to the another one, and roaming, efficient resource usage, and of course because mobile telephony has a limited battery capacity, which should be used sparingly. In general, sending costs more energy than receiving. Therefore, the amount of data sent and status messages should be kept to a minimum in standby mode. The next one was GPRS, General Packet Radio Service, in 2000. It was different than the circuit switched data service CSD, because it was packet-oriented mobile data service. That means data get transformed into individual packets in the moment of sending. The recipient received them and put packets together. When GPRS is active, there is a virtual always-on connection with the receiver. When sending data to the radio room gets occupied, in the meantime it's free. Therefore, no radio channel needs to be permanently reserved, as with CSD, for a user. Therefore, the costs of GPRS connections are usually calculated by volume of data transferred and not according to connection time. After that, in 2006, Edge was deployed. Edge upgrades the GSM standard modulation, GMSK, which means Gaussian minimum shift keying, to 8 PSK, 8 phase shift keying. For this reason, it was possible to get the third amount of bitrate. It should be like 384 kilobit per second. It extended GPRS to eGPRS, enhanced GPRS, and HSCSD to ECSD, enhanced circuit switch data. Edge could be easily integrated in existing mobile systems. It doesn't disturbing existing mobile telephony. They just had to upgrade the software of the GSM base station and change some components of them. Edge evolution or evolved edge or E-edge is an upgrade of edge with better bitrate. This was achieved by various measures. For example, by halving the transmission time intervals from 20 milliseconds to 10 milliseconds latency, using two carrier signals, or with a higher symbol rate like 60 or 32 QAM, which is Quadratur Amplitude modulation, which was a modulation method for amplitude modulation and phase modulation in combination. And other things for these measures were the improving of error correction, and of course a dual antenna can improve the signal quality.
The next generation was UMTS, Universal Mobile Telecommunication System. It was deployed in 2008. Its use of code division multiplex or code division multiplexer assays is a multiplex method which allows the duplex transmission different user data streams on the same frequency range. Therefore, higher bit rate got possible. UMTS compatible devices can use more data streams at the same time, sending and receiving. It's possible to receive a phone call and emails at the same time simultaneously. After that, in 2010, was HSPA deployed. It is high-speed packet access. Its higher bit rate from 3.6 to 7.2 megabit. It is divided into HSD downlinks PA and in the HS uplinks PA. It uses the MIMO method. MIMO means multiple inputs, multiple outputs, which use several transmitting, receiving antenna for wireless communication. That was the basis for spatial coding methods, which use different dimension and time for image transmission, space-time coding, that improved the quality, error detection, and bit rate of wireless connection. MIMO system could transmit more bits per used head bandwidth. HSPA Plus is a combination of MIMO and 64 QAM. The target was the improving of efficiency, max data transfer rates, and latency.
The fourth generation was deployed in 2009, and that was LTE, long-term evolution. It is based on GSM or Edge and UMTS, HSPA network technologies, and it was increasing the capacity and speed using a different radio interface together with core network improvements. LTE is a natural upgrade path for carriers with both GSM UMTS networks and CDMA 2000 networks. CDMA is code division multiplexing, and that is a method for optimized voice and data transmission. A low-frequency data signal is time multiplied with a high-frequency pure CDMA, an example of multiple access, where several transmitters can send information simultaneously over a single communication channel. This allows several users to share a band of frequencies. To permit this without undue interference between the users, CDMA employs split spectrum technology and a special coding scheme, where each transmitter is assigned a code. CDMA is used as the access method in many mobile phone standards. The different LTE frequencies and bands used in different countries will mean that only multiple band phones will be able to use LTE in all countries where it is supported. In Germany, we have the following bands and frequencies. For uplink and the telecom, we have 1700 till 1730 megahertz, and downlink 1805 till 1825 megahertz. Okay, let's come to the last one. The 5th generation. They think it would be ready in 2020. It's NGMN, that is Next Generation Mobile Networks. It uses OFDM, orthogonal frequency division multiplexing. It's provided as a specific implementation of the multi-carrier modulation, a modulation method that uses multiple orthogonal carrier for digital data transmission. The method is a special form of FDMA, frequency division multiplexing, wherein the orthogonality of the carrier by a crosstalk between signals is reduced. The adjacent carriers are modulated. At first, the transmitted useful information with high data rate gets divided into partial data streams with low data rate. These partial data streams gets each for himself a conventional modulation technique such as QRM with low bandwidth, modulated and then adds the modulated signal. In order to distinguish the various signals in the demodulation in the receiver, it is necessary that the carriers are orthogonal to each other in the function room. This causes the partial data streams affected as little as possible to each other. The advantage of OFDM is that the data transfer can be easily adapted to the specific features of a transmission channel by a fine granulation. If there is a narrow band interference within the OFDM signal spectrum, affected carriers can be excluded from the data retransmission. The entire data transmission rate drops only a small part. In a wideband QRM with only one carrier, a narrowband interference in the transmission channel can make the entire data transmission impossible. Even destructive interference by multipath affected only individual carriers. At least here you can see some diagrams I've made for you with the bitrate of the different methods. I put it in two diagrams because the amount between the lowest and the biggest are too much. So if you compare HSDPA with the other force on the left side, it is too less in comparing with the next generation mobile network. But here you can see some data. We have normally for GSM 9.6 kilobit, for GPRS 53.6. In the edge method we have 220 kilobits. UMTS is around 384. HSDPA is nearly 40,400, and normally our LTE is between 100 and LTE plus 300,000 kilobit or 100 and to 300 megabit. And our next generation mobile network NGMN should be around 1 gigabit per second. And here you can see our list of references we used. Okay, that's it. Thank you for listening.
非常谢谢大家，这里我要感谢一下我的同学 Benjamin，谢谢。